Welcome to a presentation about SMPE, System Modification Program Extensions. We will start with SMP Who, and discuss the roles in the system modification process. SMP What, is about the requirements for a system modification program. Then we will briefly mention some history. And the main part of the presentation is SMP How, where we will delve into SMPE internals. We will see how to explore an existing product. We will go in details with the installation process as seen by the installer, including how to undo a fix. The second half of the main part is a discussion about how to create a software package for SMPE installation. We will have some hints and tips about frequent errors, and finally have a list of manuals and knowledge center locations. There are no IBM disclaimers in this presentation, as it is a user experience session. But it is not for the faint-hearted. The speaker is definitely a dinosaur. Here we have two of them. The primary roles in the SMPE process are the installers, which are normally systems programmers. Then the auditors, who like to know which version of which program updated our data. And finally, the packagers. That is, the person that takes a product and builds an SMPE installation around it. The intended audience for this session also included developers, who can use this as a phrasebook to better understand some of the terms of the systems programmers. It is a complicated task to install system software on a mainframe system. The installation needs to be consistent and robust and support versioning. It must make sure that fixes with known errors are not applied to the system, unless the impact of not doing it are worse than the effects of the errors. It must be self-documenting, because we do not have the time to write all those details down by ourselves. It must make each product adaptable to the others, since they usually have strong interdependencies. It should be common for IBM and other vendors to have consistent process for the systems programmers. And it must be tolerant of the syntax used by packagers, since it is used in so many different products by so many different persons over a long span of time. It should not try to handle configurations, but have the possibility to protect existing configurations against consequences of new fixes. And it should not try to handle application software, which is better handled by source control management products. You can regard SMPE as an interpreter that executes a simple language called MCS, modification control statements. Each system modification processed by SMPE is composed of two distinct types of data. Instructions to SMPE identifying the elements included and how to install them. And the actual element replacements or updates. The instructions to SMPE consist of a series of control statements. Each statement has a number of parameters and options that will not be mentioned here. This is a list of the basic statements. These are statements for the Unix file system. And these are statements for data elements, such as rexexecs, panels, parameter members, procedures, samples, and skeletons. The XXX sequence represents a language code, such as ENU for US English and DAN for Danish. System Modification Program Extensions is a product that has been around for a very long time. But it is still very much alive. It is part of ZOS, and it can handle everything from assembler modules to Java jar files. But the documentation is probably some of the worst in IBM. Now, let us dig into the internals of SMPE. This is a quick list of the most important internals of SMPE. The CSI is the Consolidated Software Inventory. It is the control data set of SMPE. It consists of one or more vSAM files. REL files are a set of data sets, which are used for packaging of sources and modules for transportation. The target libraries are all the data sets, which form a runnable system. You will also install a set of so-called distribution libraries, which in effect is the backup mechanism for systems and fixes. They contain data sets with unmodified source and single object load modules to be used in the event of having to roll back a fix. FMIDs are a structured naming convention for products and features. A DDDEF entry contains the information SMPE needs to dynamically allocate a specific data set. It is a mapping of data sets and high-level qualifiers. SMPE also has a set of options. We prefer to set the purge option to have all accepted PTFs removed from the SMPE temporary store data sets. As an installer, you will see target and distribution libraries, but no source libraries. Source libraries only exist on the systems of IBM and other vendors. Before you start the installation of a product, you must prepare the SMPE environment. You run a job to create the CSI and other related data sets. And you also need to tell SMPE about your existing system. The product documentation should tell you which other products you need to know about. This is a list of the most common SMPE-related data sets for a given product. The IDZ product to the left only has a single CSI vSAM data set. MVS on the right has separate vSAM data sets for each of the zones. This is done to mitigate the size of the MVS SMPE environment. Let us see how to explore the SMPE records of an existing product on your system. We will find the name of its CSI in the ISPF dataset list, and then use the SMPE panels in ISPF to find its FMIDs. On this system we happen to have 447 CSI data sets. Luckily the naming convention is rather consistent. Then we start the SMPE panels in ISPF. We have entered the global CSI for MVS and selected Administration. Next, we select Definition. These are all the zones and the CSI datasets for MVS. Please note the three types of zones: Global Zone, Target Zone, and Distribution Library Zone. We select the Global Zone. Select Zone. Here we can select a list of all FMIDs for MVS. The MVS CSI is the largest one on your system. There are no less than 113 FMIDs on this one. An FMID represents a product or a feature. Let us take ALU 600. H normally means the base feature of a product. ALU is the three-letter acronym for Node.js, which is one of the newer languages on ZOS. 600 means version 6, release 0 and modification level 0. The next main topic of this presentation is the SMPE installation process. You start by getting an installation package from IBM or another vendor. You receive the package into the global zone. Then you apply it on the target zone. Now you have a runnable system, so you would now configure it, test it, and if the test was successful, you would deploy it on your test and other systems. When you feel comfortable with the level you have installed, you can accept it into the distribution zone. You would do this at latest when you need to put new fixes on the system, so you had a point to return to. The restore command replaces the affected elements in the target libraries with the unchanged versions from the distribution libraries. With the reject command, you can clean up the global zone by removing all sysmods that have been received, but not installed. If you have accepted something that you want to get rid of, you can resort to deleting everything, both data sets and the CSI, and then start all over again. We will now look at each step of the process in detail. You start by ordering and downloading the product or the fix. It is the same procedure for a full product or one or more fixes. The transportation has evolved over the years. Today we do everything by download over the internet. This is the home page of IBM Shop Z, from where you would order and download. The installation package consists of a program directory, a README file, an SMPMCS dataset, and a zipped package of REL files in the PAX format. The program directory is a PDF with human-readable installation instructions. The README text file contains a job. The steps of the job first unpacks and then unzip the PAX package. Finally, it extracts a PDS with further installation JCL. The SMPMCS dataset is a directory of modules for SMPE with instructions on where and how to store each of them. The REL files contains all the rest of the material. This is the first part of an SMPMCS dataset. The header describes the FMIDs of the package, how many REL files it contains, and instructions about every element in the package. syslib denotes a target library, dislib denotes a distribution library, and the REL file instruction says where to fetch it. This is the next part of the SMPMCS. Note the different types, such as ISPF skeletons, samples, programs, and Unix shell scripts. Most products would not distribute complete programs as load module, as this one does, but as modules to be linked by SMPE. This is the beginning of the JCL in member, which mostly contains link editing JCL. High-level qualifiers in this JCL will be replaced with high-level qualifiers from the DDDEF definitions. This is an example of the jobs in the standard installation job stream. Before running anything, you must start by defining an alias for a user catalog for the high-level qualifier of the product. Then follows a job to allocate the CSI and other related data sets. The received job stores the package under SMPE control. It means that it copies the unzipped REL files to another set of REL files and updates the control data in the CSI. It also stores any hold data, which is information about known errors and things you must do when you install the product or the fix. The first part of the output echoes the SMPMCS. Then follows information about what has been done. A lot of members have been copied from a REL file with IBM as second-level qualifier to a new REL file with Global as the second-level qualifier. SMPE has now recorded an FMID called HALG300. It is a function, and it has been received. Next, we allocate the target and distribution libraries for the product. Target libraries are identified by an S as the first character, and distribution libraries by an A. Then follows the three-letter identifier of the product, and finally 4 characters identifying the dataset type. ZFS libraries often fall outside this naming convention. This job allocates and initiates a ZFS file system, if the product has data in ZFS. Another ZFS job creates the Unix file structure inside the ZFS. SMPE needs to know all the DD card definitions for dynamic allocation. Here are a few more. A glance inside the ISPF panels shows us the DD defs. Now everything is ready to run the apply job. This installs the rel files as a runnable system by copying or link editing elements into the target libraries. The apply job is quite simple. You would run it twice, once with the check option, and later without it. We can see normal copying, HFS copying, and deletion in this output. There would also normally be link editing output. There is a report about each single element here. Please note the element types. This corresponds to the instructions in the SMP MCS. Copying and link editing are reported in detail. A glance at the panels shows us that the product has now been applied. Now we would do all the configuration work to make the product run. This is done outside SMPE, but if we want to protect our configurations against being overwritten by later SMPE fixes, we can create a user modification and apply it to tell SMPE to object, if it is attempted. You would then reject the user modification, apply the fix, and then reapply the user modification after checking for consistency. After configuration follows test to make sure that everything works as expected. After a successful test follows deployment to your test and production parse. When all tests have been successful, you can accept the product or fix. Normally you would always accept a new product or version at this stage. In most cases you would not accept a PTF, before you had to apply the next one. The accept job is as simple as the apply job and should be run with check and then without it. The output shows us that SMPE now has copied all the modules and unmodified sources to distribution libraries. And the panels show us the accepted state of the product. There are 3 different actions related to undoing a fix. Undoing a fix should of course happen under SMPE control to keep consistency. A restore will copy sources back into the target libraries and relink load modules into the target libraries using objects from the distribution libraries. Reject will delete a fix from all libraries and tell SMPE about it. If you have accepted a fix and find out that it was a mistake, you have only one option. You must delete the CSI and all other SMPE and product datasets and start all over once again. We are now turning to the last main topic of the presentation. How do you package a product with SMPE? The first issue is to have parallel link editing processes for the system where you develop your product, and for SMPE. This is a normal compile and link edit process. On the right we have the link edit step. We link with the call parameter, and we use a syslabdd card to define all the libraries on our system, like the language environment and the CICS load library. And we add any other objects to include in the load module. This is a compile and link edit process that is customized for SMPE. We have 2 flows on the left. The first one is done on the vendor's development system. We link with the no-call parameter without any syslabdd cards, and without including any other objects in the load module. The result is a single object load module. This format is necessary for the PTF process to work. This is shown on the right side. The second flow is the link editing done by SMPE on the customer's system. On the right we have an example of a ddef statement as displayed in the ISPF panels. Finally, we have the link edit statement from the JCL in as used by SMP. Here we have the call parameter, the syslab statements, and the include statements that were omitted in the process on the left side. When a vendor has developed, built and tested a product, it is ready to package with SMP. Let us look at the library structures as seen by the packager. The source libraries are the ones used by the vendor to develop the product. It might have all kinds of names, but it makes life easier for the packager to use the same names as the target system. This is the target system, that is an exact copy of the product source library structure. The distribution libraries have a module library added for the single object load modules. On the other hand, there are no load or auth libraries here. If the vendor distributed pre-linked programs, then these libraries would be present in the distribution structure. This is an example of a rel file structure. By convention, F1 contains the JCLIN, and F2 contains the installation jobs. The other ones can be set up as the packager finds suitable. The only restrictions are the formats of fixed block 80 bytes or unformatted library, and that members of different target libraries can have the same names, so they must be separated in the rel files. Like a rexexec with the same name as a skeleton. This is some SMP MCS code. JCLN is in rel file 1. We have a sample in rel file 2, which is applied to target library SABC SAMP and distribution library AABC SAMP. We have a Unix shell script in text format with access mode 755. This is the JCLIN that we have already discussed. The program directory is a PDF document, which is quite identical between all products. The only thing a packager would change between versions would normally be the version numbers of the product itself, and of its prerequisite products. The README text is distributed in human-readable form. It contains the initial instructions to upload the package to ZOS and a batch job that do the first step of the installation. This is a list of the usual installation jobs as copied by the README job. Let us now turn to the jobs that a packager can use to create an installation package from a source system. The first job, that we have chosen to call allocrel, allocates the data sets for the package. The next job extracts CICS definitions from a CIS system, where the CICS components of the product are running. The third packaging job will populate the rel files. The single object load modules must be copied using IEB copy. Source elements and Unix elements, such as Java jar files, are generated using IEB gener. The fourth job uses the zip utility called gimzip. It zips each rel file individually, and also the SMP MCS file to zip files. It adds some metadata used by the installation jobs. The fifth job uses the Unix pax utility to compress all the zip files from the previous job together into one pax file. A fix is created in a similar way. Finally, a few hints and tips. Sometimes you get this message when you run an SMP batch job. It ordinarily means that somebody is using the ISPF panels with the CSI. In most cases you will find that somebody to be yourself. At other times the apply job will fail, because you cannot update Unix elements. That is often caused by ZFS datasets mounted as read-only. They should be changed to read-write, at least while you are doing the installation. And sometimes apply fails because you are missing some fixes for other products. We once had this case with an IBM debugger installation, where we needed some fixes for the PD Tools common component. A closer look at the SMP MCS showed a long list of if-conditional requisites that we had overlooked. This is the long story about conditional requisites. They also can be displayed in the panels when you have run the received job. The missing PTFs needed to be ordered and downloaded from ShopZ at IBM. If you have the privileges, you can download them to your workstation or directly to your ZOS system. They must be uploaded to a ZFS directory on ZOS and received and applied by SMPE before you can rerun the original applied job successfully. If you use IBM Developer for Z, and you would like to have a simple SMPE editor, you can download one from GitHub. We have a few links to the SMPE documentation now. The first four are both for installers, auditors and packagers. The fifth one is the Bible for packagers, but probably the most difficult IBM manual ever, much more difficult than Principles of Operation. The sixth one is the Current Knowledge Center. To summarize this presentation, we have started the roles in the system modification process and the requirements for a system modification program. In the first main part of the presentation we delved into SMPE internals and went into details with the installation process as seen by the installer. The second main part discussed how to create a software package for SMPE installation. We have had some hints and tips about frequent errors, and a list of documentation locations. Thank you for listening to the presentation from ZACT Consulting.